Okay,
Yes.
okay. No, congratulations. I only ask because I wonder, like, one thing that I know there's a lot of discussions around is that are the medical students and residents who are obviously in a very short time going to become attending physicians, do you guys have exposure to, the concept of AI, the deployment of AI? As doctors, how to use it in your day to day? And I think that's like a pretty critical need right now. Okay.
It's something that we've done actually on research. So they're using AI.
I'm a team fellow at Jefferson,
Okay.
and I can say I've been part of some of the deployments and constantly be listening on some technology that we already use, as well as working with vendors who we've previously worked with and now ongoing deals who are now wrapping AI into their
I
products.
see. I see.
It's kind of interesting,
Hmm.
and there's very much so the new governance committee
Right. Right.
and all of that. And I think everyone's inventing the wheel independently on that for
Yeah.
the most part. Our wheel is starting to turn, I guess you could say, and it's really ratcheting wheel. Probably sooner. I think it was a little bit of the Wild West briefly, and then now there's a pretty good process for what problem is solving, how are we going to go about this,
Yeah.
what's the development hill going to look like.
Right. And it's interesting you say that because, in a way, it still feels like the Wild West because there's no standards, right? There's no best practice guidelines in terms of how do you vet a company, right? And it's interesting that sometimes that happens at the department level. And as a doctor, you're supposed to take on responsibilities or things you aren't necessarily taught to make these big decisions that affect your patients. So it's in a very exciting time. So great, great. Thank you guys. Is there anything else? We have time. Yeah, just so I can just sort of we can gauge the audience. Was this helpful to you guys? Was it too broad, too specific? Anything you wanted us to talk about more? It's okay. We have thick skin. We trained on the East Coast, so it's nothing can hurt us.
Do it again. Just because like it's all pretty novel to me.
Gotcha, gotcha.
Some of the terminology that you mentioned, maybe I'm not yet. And so, I think it's kind of listen to it and the process. It's great.
Oh no, thank you guys for that feedback.
To ask as well.
Because like we were talking about, I feel like it's almost like basic concepts of AI and their development and implementation will probably be part of medical education, or has to be in some way, so that you can actually evaluate the models that are being deployed, right? So I feel like that's super important.
At the same time, like right now, it's very out of domain for physicians to vet an AI model or program or product. But increasingly, big tech wants to get involved in healthcare, right? $1 trillion industry, they want a piece of the pie. I have my opinions around that. So,
Me too, yeah. We can get started, but I miss the day when the only tool that you have, or many tools, obviously, your brain in your hands, but like a stethoscope, and you're a doctor, and now we have ultrasound, and now we have AI models, and I just feel like there's just so much to learn. It's like exponentially. 2 minutes.
Yeah.
Oh, you got it, absolutely.
So with some of the AIs, we have a couple of models, and some of the internal institution created AI, people who are in the department, the institution, that are going to help you solve problems with AI. If there's another model, you go to a vendor, or they bring you a product, how are you doing either? If you're internal to your institutions that are helping you solve these problems, then when you do that, are you basically saying, hey, can we help you, or are you going to them saying, God, we need help? How's that work?
Curious about the Yale culture and approach. That's fascinating. It's very institution dependent.
So, there are a couple of projects that we're working on, internal chatbots for clinical protocols and internal policies. And we do have, faculty researchers who are passionate about that. And we're working on that kind of in-house and talking with other folks in, other centers. They're also kind of doing that. But interestingly enough, there was a company that I was talking with, their product wasn't what we needed. And then, they were like, what would you like to see, in the future, and kind of told them like, hey, if this existed, it would be great. And then so a couple months later, they have created exactly that in a secure space for us. And so we're kind of in the process of drafting like a contract stuff right now. And so it's just like these opportunities kind of arise. And with these startups, they're doing MVPs all the time. And so, well, one moment, they might not have something for you, and they might iterate something that could work for you in the future.
It's a good question. I think that if it's something that can be built, like you can get to proof of concept really fast at your institution, and you don't require a lot of pipelines connected together, then I would say internally is best and fast. But if you need a lot of pipelines connected together in terms of like a large model that lives on complex cloud hardware that can make phone calls and things like that, that's probably hard for an institution to spin up quickly.
All right,
That
good.
takes us to 4:30. Can we get started?
Yeah, perfect time. I feel like getting to know the audience is like the best part of giving talks. So thank you guys for being very interactive too. So the next talk is called Code Breakers, right? It's a really cool title there. And now we're going to be talking about design thinking and how can you use that concept to build AI solutions in the best way. And again, I'm your speaker. One of the speakers, Andy, EM faculty.
Dev, ED faculty, work with Andy closely.
Wendy, Yale administrative fellow.
I know that it seems like most of the audience is the same, so thank you guys for staying. All right, and so again, nothing has changed in the 30 minutes here, no disclosures. Yeah.
And of course, we'll start by looking at some of the core principles of design thinking. Think about identifying appropriate clinical problems and applying design thinking to develop solutions.
I just have to ask again, how many of you guys have heard of design thinking? All right, so more of you guys. And do you guys know, probably not the name, it was developed in the 50s to 60s, I believe, but it was very much popularized by IDEO. Do you guys know that design firm? So cool, yep. Developed the mouse, which I think is a technological genius invention. Anyway, so just to, for those of you who don't know, it is a five-stage innovation process that is human-centered, and the first step is really empathizing with the user. So who is the user of your product, your tool, whatever you're building, right? Is it the doctor? It could be the doctor, the nurses, the staff, the patients, their families. What is causing them great pain? As we call it, a hair on fire problem. And really taking the time to sit down, speaking to them, and defining that problem. Once you define the problem, you get a bunch of smart people, doctors like yourselves, nursing staff. You also get multidisciplinary teammates, like people who build software, who are designers, who are researchers, and together you prototype something. And that something can be as simple as even a PowerPoint with hyperlinks, and you push something and it goes to another screen. It doesn't have to be so sophisticated, but you test that with your users who, in our case, the examples we give are other doctors. And we go through the cycle. Hopefully you go from testing to prototyping, but you can go back to the first step if you feel like the product you built is not working. And it's very much an iterative process, which means you do it over and over again until you build what you like and your users love it. All right, any questions about this? All right, so very quickly, just to summarize, hair on fire problem, what is causing you the most pain in your department? Get a lot of smart people together, all right, you prototype a solution, and then bam, AI solution, you're done. Talk is over, you guys can go home, right? It's that simple, right, Deb?
Hold on.
All right.
Hold on. It's complex, right? And we all know it's complex. And one of the reasons that it's complex is there's an interplay between the model, the capacity, and the action that's needed to be taken. So, show of hands, who works at a gigantic 1,000-bed plus academic institution? I see a couple. Who has worked at a less than 30-bed ED? Right? Completely different environments. So if you take a model and a clinical workflow that was developed at a large academic center, try to deploy it at some critical access hospital, it's gonna fail. And it's not failing because the model is failing, it's because the capacity of the environment to execute on the model recommendations is completely absent. The drugs are locked behind some cabinet. You have to call the pharmacist and they have to drive in and unlock it. Like, things are not going to work out because the capacity and the downstream action of the model was not considered, even though the model performance statistics may be identical. And so thinking about how to design a clinical workflow that very properly integrates a model is absolutely key here. And a lot of the times, AI models look like they're failing, but in reality, they're just not well supported by the environment in which they reside in. And as a former surgery resident before I transitioned into ED, I was always told, Dev, it's got to look nice on the outside. The skin closures have to look perfect because if the skin closure doesn't look good, people will assume whatever's underneath doesn't look good either. In that sense, you need to be very careful about what your front end looks like. Your front end is the interface that the end user sees, right? And that's obviously supported by the back end. Whether the back end is complicated, kind of a complicated large language model or a transformer model, or it's like a simple, like a logic rules-based system, it doesn't matter. The front end also has to look good. So all of these have to be well designed. You can't just have a very complicated back end that performs really, really well, and your front end doesn't look great and is not well integrated as part of a clinical workflow. People will judge it, and that's just kind of how humans are. For those of you without a family full of software engineers that can do a front end and back end at the same time are called full stack developers. So if you ever see that phrase in like job postings, that's what they're talking about.
Yeah, so as Dev kind of mentioned, you have your front end where you want to make that user face, you know, really simple and easy to navigate, but there's also the back end. And I think, as academic emergency medicine physicians, that iteration is really important. So just to give an example, again, for folks that are joining for this talk, Triage Go is that, AI tool that helps nurses triage patients based on, mode of arrival, past medical history, as well as vital signs. And so, where a product first gets developed will definitely be different from the clinical work environment that you work in. And so that's why kind of the evaluation, reevaluation of AI tools once you employ that within your emergency department is really important. Because so for example, for us, we take care of a lot of sickle cell patients in our emergency department, and we looked at how quickly they were receiving pain medications. And per the Society for Hematology, the best, the standard of care is receiving pain medications within 60 minutes. What we found was, when patients with sickle cell came in with, acute pain, they were triaged usually as level 3, and from the nursing perspective, this is kind of how it looks in the front end of things. It kind of gives you why patients are triaged a certain way based in the supplemental information box. But essentially, we made it a priority within our administration and operations group that it was important to meet that metric to take care of a very vulnerable population of patients. So on the iterative side, we work together, and our most critical zones take care of patients with the triage level 2. So on the back end, we reiterated our process, and when when we have, this is like, from the back end, we use like and or statements. So when certain patients come in, with a history of sickle cell and with pain, then they get a triage level of 2. And so we're looking at data, but so far it looks promising that these patients are receiving pain medications more quickly.
All right, and then no matter where you work, I'm sure this is a problem for you, but how many of you guys see trauma patients who are elderly patients who fall? Yeah, all right. Everyone should be raising their hand, all right? This is a very common trauma. And what molecule is that on the at the right bottom? Do you guys know? Is a pixaban, right? So this is a patient who's fallen. Unfortunately, she's on a DOAC, and she's a trauma patient. And you say, okay, a pain point that a lot of doctors have is when would you reverse? So this is a very simple, example to just get you guys familiarized with design thinking. But essentially, I have this great idea. $1 billion. Don't worry, guys. This is HIPAA compliant. This is a test profile on Epic. But let's just say, all right, let's create a binary classifier on identifying patients who are bleeding and should be reversed with reversal. Then it could be Kcentra, it could be Indexanet. I don't know if you guys are aware of the Anexa 1 studies, so probably Kcentra. Anyway, and so we have this great idea, and what you can do is, I can't even tell you how many times that we've mocked up or products using Canva or Figma or some type of even PowerPoint and Keynote. So essentially, we drafted all these slides in about 10 minutes. Boom, I've got this great idea. In the back end, there's logic that dictates, that alerts through an OPA, the physician, the users, all of you, that you should give you should reverse this patient, Auntie here, that she should be reversed. Okay, your patient fell, she's on a DOAC, she's bleeding, and you should reverse it. And then instead of going to your Epic implementation team, because if you do, they'll hate you, and I'll tell you why, you go to the doctors and say, hey, I have this great, amazing idea, this great OPA, and it interfaces with you through this OPA, and you should totally listen to it. And they'll say, what, do you think they'll be excited? They'll say, no. Why should I do this? I don't trust you. There should be some explainability portion here, and so we're not going to use it. And so you go back, and then in 50 seconds, you make one adjustment and says, actually, there's an explanation here. Auntie fell, she's on a DOAC, she's hypotensive, lactate's up, she's pale, she's altered, her hemoglobin is dropped, she's tachycardic, shock next, blah, 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 blah. And so the doctors say, you go back to the doctors instead of your Epic team, and they say, okay, this is great, but Andy, you made my life hard. Now I have to click accept, and I have to go look up on WikiEM what reversal agent to give and the dose. And so you're just adding another click to my workflow and making my life hard. And I say, oh, it's okay. I'm going to go back and I'm going to iterate again on my, this one I did on, we did on Canva. And so this time we're going to add reversal. Based on the dosing history, you just give some additional history. When was it given? How much of it was given? And it'll recommend Kcentra, right? Genius. And so they say, no, this is dumb because there's more DOACs than just apixaban. So you're making our life hard. We have to go look that up, and then we just go back to the computer and say, don't worry about it. We're going to add additional DOACs. And so the doctors, all of you say, wonderful. This makes my life easier. There's no additional clicks. I don't have to look anything up. And so we love your idea. And once we uniformly have your approval, then we go to the Epic team and implement this. Should we do so? Because if you don't, you'll be going back to the implementation team over and over and over again, and they're going to give you the side eye. And I love this meme. I don't know if you guys recognize it, but I've always wanted to give it on a national talk, and so I'm going to do that today. So they're going to give you the side eye and say, this doctor does not know what he or she is doing. They're coming here to create a build on an incomplete product, and they're just making your life hard, and you're actually increasing the production time by months and months and months. Instead, you're going to use design thinking. Go on your laptop. You don't have to pour hundreds of hours. It literally took us 10 minutes, and then get some feedback, and then you'll be seen as a winner by your Epic team, and they will implement any build that you guys want, and you guys are heroes for the enterprise, the health system. All right, and with that, we're going to end. Please, Dr. Sun, take it away.
Yeah, so, with everything again that we do, patient care is at the, most important, front of it. And so, as you go back to your emergency departments and you implement design thinking, just creatively iterate, collaborate, get your teams involved, like including your pharmacists, your nursing, techs, like everybody, and, go home and design think.
And with that, happy to entertain any and all questions.
Your billion-dollar ideas. Please share them with your Come on. For those of you guys that raised your hands, where did you learn that? Just out of curiosity. Was it med school? Residency?
Undergrad?
Yeah, where did you guys learn that?
We was undergrad, and then in med school we had 2 months of thinking license.
Interesting. Did you guys end up with a product or an idea that came out of that course? Oh, pretty cool. Anyone else? Any questions about it? Please.
What avenues have you used within your departments for that ideation phase? Is it a weekly conference, or do you host a lunch, and how does your department respond to that?
I think it kind of comes from everywhere. Like, you have your short-term feasible projects, and then your kind of like longer-term like dream projects. And so, like, a couple of the really quick things we were able to do with Epic, like, let's say your zones change, and now you want a Epic that filters certain patients out. Like, that's kind of like, someone comes up with the idea, you show a couple people of what you built, and if you get 2 thumbs up, it could be quickly implemented versus like, something else like, what you guys did. It definitely required more iterations.
Yeah, I think it's really important to figure out who's going to be the end user and find a wide range of end users to provide their opinions. There's some like residents and kind of students in the audience, and I'll say for learners that may have a shorter time frame in that want to get involved on projects like this, it's much easier to jump into a project that's already live and try to improve that rather than like design from scratch, right? Because the designing process is not just dependent on you and your ideas and getting opinions, but sometimes it's dependent on the stage at which you are, right? So sometimes it's a lot easier to present something as faculty rather than present something as a first year resident and say, hey, this is my idea, right? And so I always recommend anybody who wants to get involved who's kind of in like the training process, jump on something that's already live and try to improve that, and there's credit to go around for everybody.
An alternative perspective, though, is the most complex software that my team and I ever built was in med school. So there's something very valuable about, you know a lot, and there are some things you don't know, and that's okay. Just taking the risk, and I would say it's great to have a room full of doctors create a solution, but I would say even better is actually finding friends in different industries. So my wife is a software engineer, and I asked her all the questions on her GitHub, and it annoys her, but it helped me learn a lot more than any textbook or class would. Right. Another thing that would help you is a designer. So what is Figma? What are these design softwares they're using? Holy moly, it is so amazing and easy to use. I can build my own products, high fidelity product mockups on my own instead of spending hundreds of thousands or even thousands or hundreds of dollars poor as a medicine. At least I was very poor. And then hiring someone, you can just do that on your own, right? Going out there and finding somebody in social media, like there's so many different industries that'll give you insights. And one thing that I think is helpful is hackathons. So don't come out of your hackathon thinking you've got the next billion-dollar idea. A lot of people get excited about it, but you can learn so much because you're working with an engineer, right? Some of the coolest ideas that came up with working with mechanical engineers. You know, on the flight here, I was talking to a fiber optics executive and learning about that industry as well. So much you can learn, and pieces of it you can translate into potential product solution ideas.
Yeah, and a lot of times you also don't need to like reinvent the wheel. Someone, the great thing about national meetings like SAEM, and you have specialty interest group like, in informatics and innovations interest group. So if you're working on a problem, pitch it out to your colleagues because someone might have worked on it and, might have done things that have been successful that you can kind of implement and reiterate and make that applicable to your home institution.
Yeah, and I would say I have a lot of friends who've gotten MBAs. Wendy and I have an MBA, and I know there's colleagues here that I recognize that are getting MBAs, and they're so great. There's also the MBA of Hard Knocks, and that is just literally doing it yourself. The most learning I've ever gotten was not in a textbook or interning. It was just getting your hands dirty and building a product. Even if it doesn't scale or get adopted or someone buys it, that learning process is invaluable.
Thank you all so much for coming today. We'll be up here for any other questions.
Thank you guys for being here.